All right, let's do some experiments here. Let's try this. That's a beautiful blue color. Let's add a little bit of acid, like 3 drops, and watch what happens. Isn't that beautiful? Shift to a green. It's kind of nice. Look at that red in the middle of the vortex. Looks like a stoplight right now. It's kind of pretty. Add a little bit more. See, we make it red. A little bit more. All right, let's try adding some blue. Not blue, add base. That's kind of pretty. A bit more. Nice. See if we get the rainbow. Not quite. I'm going to just add just a bit more. Hope we get it. Hope we get that rainbow. There it is. All the colors of the rainbow in one flask. It's kind of neat. All right. Now that's neutral. So I'm going to add a little bit more base to this reaction mixture. And boy, you can see some interesting flow patterns. When I add base, you'll notice that the color of the indicator shifts to like a blue or a violet. I'm using universal indicator, and universal indicator, thank you there, Tracy. Hey, it's good to see you. I notice you a lot in my comments, Tracy, so thanks for commenting. But right now we're at a pH of 10 with our universal indicator. Here, let me turn this on so you can see what I'm doing here. So yeah, the violet color tells us that we're at pH 10, which is very basic. And then I'll add some acid, and that'll neutralize the base, and that'll lower the pH. So that's 3 drops of the acid. Turn this off. And you can see the effect of the acid. You notice in the middle there, so when I add acid, it kind of stays in the vortex, or any material sort of stays in the middle of the vortex. There's a stable flow that sort of happens. But as that material gets pushed down to the bottom, it spreads out along the sides. And you can see indeed that the acid that I have added has neutralized the base. The reason why we know that is because when this particular indicator is neutral, it's going to be a green color. You see that 7 there, pH 7, that's known as neutral. If I continue to add acid, then the pH will continue to drop, and we'll see yellow, orange, or maybe even red if the acidity is very high. So let's add some acid here, right here in the middle. And you can see, again, that the acid stays in the center. There's a stable flow. But once it hits the bottom and hits that stir bar, it gets pushed along the side. A little stoplight effect there, huh? Looks kind of neat. And as the acid gets pushed out along the sides, then, of course, we get the shift to the red color. Now, if we add base, thank you there, Torvis, I appreciate it. If we add base, we should increase the pH. So now, we're at a pH of 3. It's pretty easy to see this is red, which is quite acidic. Things that are pH of 3, it's going to be like soda pop or, lemon juice, like pH 2. It's very acidic. And then as we add base, the acid will be neutralized. If I perfectly neutralize it, we'll end up at pH 7, which is green. And then if I add an excess of base, we might see some aqua, some blue, or some violet. So let's add some base, send it in the other direction. Sometimes, there we go. You can see that base that I've added is, yes, Tracy, you can keep it going back and forth as long as you want. And it looks like we've got the rainbow going on there. That's kind of cool when that happens. The entire flask shows all the colors of the rainbow. And the reason why that happens is the chemical reaction between the acid and base takes time. And, it doesn't happen immediately. And then you can see there's different regions in the flask that have different acidities. And so you're going to see different colors. Now that everything has had its chance to homogenize, we see the green color. So we notice that the acid has been neutralized by the base that I added. Let's add a bit more base up here at the top. And you can see some beautiful flow patterns. But as the base gets, moved throughout the solution, that's going to shift to a violet color. Hey, Oxalotl, thanks for joining in. Thanks for commenting. Appreciate that. Yeah, now we're at a very high pH. pH of about 10. That's a basic. And now we're going to add some acid to send it back in the other direction. I'm going to show you guys here, if you hang out a bit, I'll show you how you can do a similar experiment at home. Well, I don't want to say I'm going to show you. We're going to try, I should say, to do a set up experiments that you might be able to do at home. Look at that red in the middle of the vortex. You can just totally see how there's like a stable flow in there. And there's just some beautiful patterns that arise. Look at that. That violet in the middle is just really staying stable. It's really kind of pretty. Let's see. Oh, I just added acid, and I'll chase that with a bit of base. That's kind of cool. Chase that with acid. Chase it with some base. Boy, that's really beautiful. Look at that. That flow that you get with the base is really kind of pretty. It's really interesting. If we got any fluid dynamicists out there, they may be able to tell us what's going on. That's gorgeous. Just really interesting effects. There's acid. Shift to the red color. Thank you there, MH Vegas. I think it's cool too. Adding some base. It's just really pretty. I just enjoy doing these experiments, and I enjoy when folks, join along with me. We can do a few more experiments here. I like doing this one. Well, let's try to get the rainbow, shall we? I mean, anytime I get the rainbow in this flask, it's enjoyable to me. Look at that. Come on, baby. There it is. Looks like the red is gone. Let's add some acid there at the top. See if we can't regenerate some of that. Isn't that cool, Inbo? It really does span the whole color spectrum. So let's show you what's going on if you've just recently joined. I have a universal indicator in here which displays different colors depending upon pH. So these are different colors you'll see depending upon the pH or the acidity and basicity that's in the flask. Thank you there, Linbo. Appreciate it. We're going to add a little bit of base to develop some violet color. And because, the reaction doesn't happen immediately between the acid and base, you'll set up different colors simultaneously until the mixture homogenizes. It's beautiful. Very beautiful. I got another experiment I'm going to do for you here. Let's try it. Let's try this solution. Although I don't know if that... Yeah, I think it looks okay. It's the same kind of solution. I use a similar fluid as an aquarium pH meter, but the reaction takes hours. Interesting, Torvis, to show the actual pH. So you've got a pH meter that takes hours to equilibrate. Thank you there, Oscar. I appreciate that. I'm not sure I can repeat the comment. I don't know what YouTube's... I don't know what the live rules are, but I appreciate it there, buddy. Yeah, isn't that cool? You adding those different... Man, those flows are just really showing up nicely tonight. Really showing up pretty. Here's some acid I'm adding. The acid tends to shift us to a red, orange, or yellow color. There it is. And the base is what shifts it to the violet and the blues. And you can tell, I'll wait till this settles down a little bit. Cool, Oscar. So, Oscar, do you have, watch this, I'm going to add a little base up here at the top so you can see how the fluid that I add stays in the center. So there's like a stable flow in the center. Of course, once it hits the stir bar at the bottom, then it gets spread out along the side. So, Oscar, you're going to try this with your son. Do you have access to universal indicator? Just wondering if you have access to that. And if not, I can show you something that you might be able to pull this off with quite easily. Just curious. Add a bit more base. 3 drops. Chase it with a bit of acid. See what we get. A little more acid, I think. We got to get some more red in there. Get some red in there. Get the red developing. When you see the green color, that means the acid and the base have neutralized each other. Right now, we got the stoplight effect going on. That's kind of interesting when that happens. Looks like we've got an excess of acid. That's why the red color is there. We'll add some base to pop it back in the other direction. 4 drops. And we caught the rainbow. There it was. There it is. The elusive rainbow. That's so gorgeous. Here, we'll try this. So this is the same type of system over here. So, all right, same thing. But this one is buffered. So this is a buffered system. We'll get this one stirring. There we go. And so check out what happens when I add base to this one. Now you see that blue color develop, or that violet color develop. But in this case, when I add it, the surrounding mixture doesn't turn violet. It kind of just stays green. So the solution is resisting changes in pH. So the pH changes are not happening very quickly. Here, I'll show you. I'll try it with some acid. So this should turn it red, and it will in the middle, you know, because there's a high concentration of acid in the middle. I'll add a few more drops, quite a few. Like 5 drops of this stuff. And again, in the middle, you see the red, but because the solution is buffered, the pH doesn't change a whole lot, so the color doesn't change a whole lot, you know, once the acid mixes through the whole solution. That's in contrast with this one. If I try putting this one on, and I add a whole bunch of base or acid to this one, you know, the color changes dramatically. So this is an unbuffered solution. We're going to put the buffered one back on. And I'm going to add a Alka-Seltzer tablet to this one, which is actually what buffers it. But there's an interesting experiment I like to do. I hope it works. I want to do a video on this at some point. I'm working on it. So we'll get that going. I'm going to pop in a piece of, an Alka-Seltzer tablet. We can watch what happens there. In it goes. In goes the Alka-Seltzer tablet. And I see a bunch of bubbles. And those bubbles will continue to develop. And what's happening, the reason why you're seeing those bubbles is in the Alka-Seltzer tablet, there is some sodium bicarbonate and there's some citric acid. And when those two react, they form carbon dioxide gas, which is the bubbles that you're seeing. But I want you to check out where those bubbles end up. See how they kind of get caught in the vortex? Can you see that? The bubbles kind of find their way to the vortex. You can easily see it up here, right up there at the top. They kind of actually get caught in the funnel. I'm going to turn this up just a bit more. Yeah, there's a lot of bubbles in there. And so what I'm going to do after sort of the, you know, the Alka-Seltzer tablet's completely dissolved is I'm going to add some base to this, some sodium hydroxide base. And what's interesting is sodium hydroxide base reacts with carbon dioxide. And remember, that's what these bubbles are made of. These bubbles are made of carbon dioxide. So we're going to watch what happens when I add the sodium hydroxide base to those bubbles. All right, I think we're ready. Here we go. In goes drops of base up here at the top. We're going to add 5 drops. In they go. And did you see what I saw? Could you see it? What's happening to the bubbles? They're going away. That should make sense. I'm going to add just a few more drops just to get the rest of it here. They go away because the bubbles are full of carbon dioxide. And remember, I told you the carbon dioxide reacts with the sodium hydroxide that I added. And so the bubbles are consumed. So in this sense, sodium hydroxide is acting as what we call a carbon dioxide scrubber. It removes the carbon dioxide from the gas phase and actually dissolves it into the water. And, you know, people are studying how to use these in industrial processes so they could put like carbon dioxide scrubbers in smokestacks. And as the carbon dioxide moves through the smokestacks, it'll get, you know, removed by the carbon dioxide scrubbers. And that's great, because then the CO2 that would otherwise end up in the atmosphere and cause continued warming will be scrubbed out of the atmosphere. And folks are researching how to do this. Some people are using it. Some companies are using it. The problem is right now it's pretty expensive. It's expensive to put in. All right, let's try this. Let's see if we can try this with the. Where's another flask here? Let me get a. I got a flask here I can do this with. A bigger one. Uh-oh. Here, let me just pop a little. Where's the other flask? Well, we'll just try it with a little one. We'll do it with this. Okay. Try this flask here. It's a little one. All right. We're going to add some water. Let me put a stir bar in there. Pop a stir bar in there. Come on. There you go. It's bouncing around. Let's get it stirring here. There we go. Add a little bit of water. So we get a nice vortex going. I'll try to refocus the camera here so we can see a little better view of what's happening. Let me just drop this just a bit. There we go. Zoom in just a bit. Okay. I think we could probably use a little bit more water. What do you think? Let's pop it in here. A bit more water. And we are ready for some experiments. So what I'm going to do now is I'm going to test to see if this stuff... All right, you can't see it. Hold on. Let me get this light on. If this stuff here can be used as acid-base indicator, food coloring. Notice this is natural food coloring. Just means that it came from plants, fruits, and flowers. That's where this stuff came from. So let's see. What color do you want to try? We got red, yellow, green, and blue. I think I'm going to try this with the red version first. Something I've wanted to try. I've never done this before. But we're going to see if we can use this natural food dye as an acid-base indicator. So here we go. Put in some red food dye. Pop it in. Let's see what happens here. In goes a drop. Oh, wow, that was cool. That was beautiful. Let's try that again. Another, I'm going to slow that down. That was pretty enough. I want to see if I can see that in slow-mo. Here we go. Another drop. Look at that. Isn't that an interesting flow pattern? Very cool. One more drop, I think, to get the color I'm looking for. There we go. Okay, that's kind of like I don't know, I'm going to call that like a slightly purple red color. I'm going to add some acid to this. And we certainly see a color shift. Look at that. Yep, definitely saw a color shift. Let's add some base. Magenta, says Tracy. Yeah, it did look magenta. Now it's kind of more like an orangish red. Let's add one more drop here just to see what we get. Yeah, I'm going to add another drop of the acid just to see. I think we can get this color just a bit more red. Look at that. Nice. It's a nice red color. Again, it's coral. Yeah, Carl. So the food dye that I'm using is Watkins No Artificial Dyes food color. Basically, what the red dye is it's just like from beets, the beet color. And now you can see I've added a lot of acid. Let's add some base to this and check out what happens. And of course, when you add base, we get a color shift to a blue. And that's because this particular mixture of dyes contains compounds known as anthocyanins. That's a gorgeous color shift. Look at that. Really pretty. So it's working. It actually works with these household items. That's a nice violet. See if we can't get it to go to blue. 2 more drops of base. That's cool. Carly Elwin. Carl Winslow, I got it. And let's add some acid, send it back in the other direction. Boy, that's pretty. Yeah, these work fairly nicely. What do you say we try some of the other, thank you there, Carl. What do you say we try some of the other natural food dyes? That's a pretty shift. Ooh, look at that. There's your magenta. Tracy was calling it a magenta. We'll add another drop to get it to the more red color. Actually, 2 drops. Yeah, lots of neat color changes there. It's really looking nice. All right, I'll add 2 drops here while I set up the next flask. We'll get another flask going. Let's see if I got it. Oh boy, I'm running out of stir bars. All right, let's add. Hey, thank you there, Torvis. Wow, really appreciate that. Torvis sent a gift, which is really nice. I've never gotten a gift before, so I appreciate that tremendously. So let's make sure we like that. So lemon juice for acid. What are we using for base? Love some deep sunset colors like the purples and the oranges. Yeah, let's get a few more in there. So what I'm using, thank you there, Riker. I appreciate that. What I'm using for, Tracy, what I'm using for acid and for base in this particular experiment, it's not household, well, it is household items, but I'm using 20% by weight sodium hydroxide, which I actually end up purchasing in the plumbing section. So it's like a drain cleaner. And then I also buy some 20% hydrochloric acid. It's also known as muriatic acid. I pick both these up at hardware stores. But if you're using this stuff, you got to really be careful. I mean, I have, I've got eye goggles on. I probably should be wearing gloves. But these dropper bottles really make it quite convenient where I don't really need to wear them. Every once in a while, I'll spill a little on my hand, but I have some water nearby that I just use to rinse everything off. So let's try another color. Let's try, instead of this red one, we'll pop another flask on, and in this flask over here, we are going to, what are we going to use? Well, let me get a stir bar in there. Let's get this going. All right. I say we're going to try I'm going to go with the green. I think we're going to get some nice color changes with the green. So let's get this going here. A little bit of water. It's just plain old water. A little stir bar on the bottom. And then what we'll do is, I'm going to add some of the green food dye. So the green food dye, whoop, you can't see that. Let me turn this light on so you can see what I'm doing here. I've never tried these experiments before. I mean, I've used this as an acid-base indicator. I've just not tried it in this particular manner. Riker Kelly wants to go blue. We're going to do that next. And Riker, the reason why I'm holding off on the blue is the color shift there is kind of subtle. You know what? Riker Kelly wanted blue, so we're going blue. Why am I going to do what I want to do? I want to do what the viewers want to do. So, okay. So we're going to try the blue. We're going to see what happens. So in it goes. If you ask, ye shall receive. Here we go. Drop of blue. Wow, that's gorgeous. I mean, just watching it dissolve in is really kind of pretty. Let's watch that again. Another drop of blue. Look at that flow pattern, man. Go blue, baby. Yep, go blue. Look at that gorgeousness. Come on, man. I mean, that's just worth the price of admission right there. That is so beautiful. Really is pretty. Gosh, that's interesting. So yeah, people have studied flow patterns in. Thanks, Tracy. I appreciate that. People have studied the flow patterns in these stir bars, and they do indeed show that there does tend to be a stable flow that runs from the vortex down to the stir bar. Add another drop. All right, let's see what happens when we start adding some acid and base. I think that color's enough. I'm going to turn this light off. Does that look better or does that look better? I think it's either. Okay, you're welcome, Riker. Okay, let's just start adding some acid. So I'm going to add like a drop of acid here. Yeah, it may show how tornadoes work there, Tracy. Keep adding. Tracy, are you a science teacher? You kind of give that vibe. I'm just wondering. You notice that blue color, I'm seeing it fade a little bit on my end as I'm adding the acid. I don't know if you're seeing the same thing. I'm whacking it pretty good here. I mean, that's quite a strong concentrate. But yeah, that definitely is fading. The color is definitely fading. It's taking a bit, though. Interesting. It's faded, but it's subtle. Thank you there, Tracy. Okay. You know more than you give yourself credit for. Here we go. Let's start adding some base, see if we can develop the color back. It may be that, so the blue color actually comes from a protein in blue-green cyanobacteria. That is, look at that, the color's disappearing. That's known as phycocyanin. And look at that, we made it disappear, folks. I shouldn't have, you know what? I shouldn't have added the acid first because I think I denatured the protein is what I did. All right, let's try this again. Let's add, oh, that's too bad there, Riker. You don't do any kind of real experiments. Yeah, I agree. That is kind of sad. Let's add some more base here. Or excuse me, some more of the indicator. I call it in. Look at that. God, that's gorgeous. That is just so pretty. Carl, I would say yeah. So these, these different dyes that are in these natural food dyes, a lot of them do break down in, when you shine UV light on them. So I'm adding acid now, which is lowering the pH. And sure enough, as I'm doing that, look at that blue color come back in. Come on, that's cool. Come on, that's cool. All right, now we're going to add base and make that color go away. 1, 2, 3 drops. Look at that, folks. Riker, I'm so glad you asked me to do the blue. I didn't think it was going to work, and look at me. Look at me looking like a fool. Riker should be in here doing the experiments. All right, let's add the acid to make the color regenerate. Look at that, folks. It's coming back in. What a glorious experiment, huh? Go blue, Crump! Hey, how's it going, buddy? Former student has entered the chat. He is a University of Michigan student. That's awesome. Tell me what's going on there, bud. I want to hear how your classes are going, all that business. So Gregory, man, he's one of my best students. Absolutely one of my best students for sure. Yeah, hey, how'd you like the football this year? I enjoyed it. So we're both Wolverines. Yeah. Pop some acid in, develop the color, pop in the base, take the color away. It's interesting. It's working. Riker, I'm so glad you made the suggestion. Just a great little experiment. All right, I want to try the green now. Y'all okay with that? I want to try the green color. I hope you're all okay with that, because that's what I'm doing. I don't know what's in there. I don't know what's in there either. Do I got a flask? Come on, I got to have an empty flask. I do. Here we go. About to start your third year clinic. Wow, third year. Man, third year in grad school. It's crazy. Time flies, my friend. All right. I don't know if you heard, Crump. I'm at Wayne State now. That's right, Riker. We're going green now. All right, here we go. I got a little stir bar in there. That's gonna be nice and tiny. That thing is just oh boy. That thing does not know what it wants to do. We're gonna have to go a slow speed. You see the glass is tilted a little bit, which is gonna mess things up just a bit. Maybe as I add the water, that may tone it down just a little bit. Yeah, there we go. There we go. We got a nice easy flow there. We're gonna add some green dye. It's a lot of fun, man. Here we go. A little bit of the green dye. Well, that was interesting. Oh yeah, this green dye is really kind of syrupy, as you can tell. I'm gonna have to get the stirring going just a little bit better to get it going. Oh, look at that. It's being difficult. There we go. Chop it up. All right. Let's get a nice flow going. All right, now I'm going to add a drop of green. Here we go. Look at that. Oh, man. Let's see if that little drop of green food dye will actually... Look at that. It's like it's trying to survive. Stay away from the stir bar. You will be assimilated. I didn't expect it either, Wolf. I think that's fairly green. I don't know about y'all. All right, let's start adding some, we'll add some base to this, okay? So here we go. I'm going to add a drop of base, see what happens. Oh, you get a red color develop. Look at that. Nice red color develop. I agree, Air Riker. I'm going to add another drop of the, hey, wait a minute. I thought this was a green dye. I haven't seen green yet. All I've seen is orange and yellow. Let's add some acid, see if we can develop the green. I don't know what's going on here. There's 2 drops of acid. There's 3. Yeah, we could add some quinine. I don't have any with me. They are sweet there, Wolf. That's a little slightly green, isn't it? I'm going to keep adding some drops of acid, see if that green color can get like a little deeper. I guess not. I guess we're kind of stuck at yellow, huh? I wonder what would happen if, let's see if I can get it to the green. I had a drop of base. Yeah, it's just a really nice. I'm gonna add a drop of the happy little chartreuse. I'm gonna add a drop of red to this. So we got 2 different indicators. Oh God, that was oh wow, was that beautiful? Do y'all see that? That was a really interesting flow pattern. I mean, just really gorgeous. I'm gonna have to do some videos on that. See if you can see it here. Oh, no, I missed it on that one. You can still see a little bit of it going on at the top. Really cool. All right, here we go. What am I adding? We're gonna add some base. See what happens here. We add a bit of base. 2 drops. Let's watch what happens. It's kind of like an angry. Oh, it all reacted away. Let's add some more base here. So you can see the base is trying to change it to a blue color. The stir bar is not the greatest. It's kind of like I don't know what to call that, like a wine, like a sunset. So there's your base color. That's fairly basic at this point. And now I'll add some acid and we'll see what happens in the other direction. I'm gonna have to clean all this stuff out. There's 5 drops. Yeah, look at that. Back to yellow. Back to yellow. It's a bit more. The sangria. Yeah, I agree. I agree. It's pretty. That looks nice. Yeah, the green was a little disappointing, to be honest with you. To be honest with you, I didn't like that a whole lot. Let's pop the, let's do the bubble experiment one more time. And then I think I'm gonna, Let's see. Got to move it back. Got to move this up. Where's my... It's going to be right here. I like the bubble experiment. Let's get this on here. All right. Let me raise this up so I can see everything a little bit better. There we go. Oh, I love it. Carl's got the naming of the colors down for sure. Here we go. We're gonna add a Alka-Seltzer tablet to this, and we're gonna watch what happens to the bubbles. Look up there at top. There's your vortex. That's gonna be a nice one. In goes the Alka-Seltzer tablet. That's producing a bunch of bubbles. And check out where those bubbles end up. See how they run down into the funnel? They kind of build up. They go down into the vortex. We want to build up a bunch of them. It's a good question. So, Riker, what I use to color this particular one is a mixture of chemicals known as universal indicator. So this one has the rainbow indicator in it, which displays these colors at different pH values. So you can see this one is slightly acidic. It's like a greenish yellow color. A little bit more yellow than green, so I'd call this like a pH 6.3, 0.4, somewhere in there. It's just slightly acidic. And what I want you to notice is the bubbles that are produced from the Alka-Seltzer tablet. That happens from the reaction between citric acid and sodium bicarbonate in the Alka-Seltzer tablet. And all that carbon dioxide that's produced, it's kind of interesting how the bubbles end up in the funnel. I don't know if you can see that, but you know, the funnel used to be kind of transparent. Now it's cloudy because there's all those stinking bubbles in there. And now what I'm going to do is I'm going to add some sodium hydroxide to the funnel. And sodium hydroxide reacts with carbon dioxide. And that'll be easy to see. It reacts with it, and it actually makes something that dissolves into the water. So you can watch what happens to those bubbles when I add the sodium hydroxide. Look at that. Look at your funnel. See how your funnel is losing the bubbles? That's because the carbon dioxide in the bubbles is chemically reacting with the sodium hydroxide that I add, and then it's forming a salt that dissolves in the water. So in this sense, the sodium hydroxide is actually removing carbon dioxide from the gas phase and causing it to dissolve into the surrounding fluid. And in this sense, it's acting as what we call a carbon dioxide scrubber. Carbon dioxide scrubbers are materials that remove carbon dioxide from the atmosphere and fix it into a solid or into a liquid so that it's no longer in the atmosphere. And you can guess that that's pretty important, as we continue to burn fossil fuels. It's good to have ways to remove the carbon dioxide from the atmosphere so it doesn't continue to have the warming effect. We can show you this one more time. We're going to add a Alka-Seltzer tablet. That's going to produce a lot of carbon dioxide gas, and that carbon dioxide gas will show up as bubbles. And check out where the bubbles go. You're welcome, Riker. Look where those bubbles go. So the bubbles are forming from the reaction between citric acid and sodium bicarbonate in the Alka-Seltzer tablet. It produces carbon dioxide, and interestingly enough, the carbon dioxide bubbles that form, look at how they get trapped in the funnel. That's pretty much where they end up. And once that all kind of, settles down, I'm going to scrub the carbon dioxide out. Yes, actually, Wolf, thank you. I do not know why I didn't think of that, but great point. Scuba divers also use those scrubbers, because as you exhale in a self-contained breathing apparatus, while you're inhaling oxygen, you're also exhaling carbon dioxide, and there's too much carbon dioxide. You don't feel so good. Great point, Wolf. And in space, absolutely. I think they use lithium hydroxide they have in spacecraft. I wonder if any similar process were used in old sci-fi movies as practical effects. I don't know, Torvis. All right, you see how all those bubbles ended up in the funnel? So that's a bunch of carbon dioxide. And now what I'm going to do is I'm going to, so to speak, scrub submarines, Douglas. Great point. I'm going to scrub the carbon dioxide bubbles out of the funnel with sodium hydroxide. Sodium hydroxide reacts with carbon dioxide gas, and it forms a salt that'll dissolve in the surrounding water. So here we go. Check it out. I'm going to add the sodium hydroxide and just watch what happens to all those bubbles. See how they disappear? So what's happening is the carbon dioxide is reacting with the sodium hydroxide that I have added, and it's forming a salt that dissolves into the water. The gaseous form of the carbon dioxide is getting converted into a form where it dissolves in the water. And in that sense, we call sodium hydroxide a carbon dioxide scrubber. And a lot of folks in the chat have mentioned some practical uses of carbon dioxide scrubbers. I don't mean to steal their thunder, but I guess I'm the only one talking in this live. But Douglas noted that people use these in submarines because when people are down in subs, then the exhalation of carbon dioxide, if that builds up, it's going to be bad. So they got to have something to remove that from the air when you're self-contained in a submarine or with scuba equipment, self-contained breathing apparatuses. Hey, Riker, thanks for joining in. Hey, thanks there, Adam. Great to have you along. And this is, I'm working on a video on this. It's probably just a short form video. So this is a video I'll probably have coming out where I talk about, just this particular reaction here. I got to figure out a way to catch it. And, that looks kind of interesting and that people might find kind of cool. So if you like it, let me know. If not, you think it's a video that won't do very well, you can let me know that too. Here, we'll do it one more time. I'm going to take this Alka-Seltzer tablet, dissolve it in the water. Well, it's not being dissolved in water. What's going on is the Alka-Seltzer tablet, the sodium bicarbonate, and the citric acid are reacting and forming carbon dioxide bubbles. And check out where those bubbles are ending up. They get trapped in the vortex. I mean, you can see a bunch of them out here, of course, but look at here in the middle. All that vortex looks different now, and that's because there's a bunch of carbon dioxide bubbles that get trapped in the vortex. And then I'm going to scrub those bubbles out. Thank you there, Carl. So I should explain more details, eh? We'll try that. So notice now that the bubbles have sort of dissipated out of the surrounding area, we can see that they're trapped in the vortex quite well. And that all those bubbles, of course they have a water-based surface, but the interior of those bubbles is carbon dioxide. And we see it's persisting there. What I'm going to do is I'm going to clean up the carbon dioxide, so to speak, by adding sodium hydroxide. So here we go, and sodium hydroxide chemically reacts with carbon dioxide. And we can see the effect. I can actually hear the effect of it. I hear it hissing. But as I add, look at that. Look what happens as I add the sodium hydroxide. Look at how that vortex cleans up. The bubbles are being removed. And the reason why the bubbles are being removed is because sodium hydroxide reacts with carbon dioxide, and it converts the carbon dioxide into a form that dissolves in water. Even though short form seems to be at a short attention span, I feel... Carl, my shorts do really well. My long form, not so much. I put a short out and it usually gets at least 10,000 views pretty quickly. But yeah, check it out, man. The bubbles are gone. They are gone. And that's because the sodium hydroxide reacted with the carbon dioxide and dissolves. Hey there, Lila. Yeah, you're a bit late. I don't know how much longer I'm hanging in here. But I can show the experiment we've been doing. I'll do it one more time. Maybe a couple more. If some more folks join in. Who knows? See, here we go. We almost got to 100 viewers, I saw. You just tried to clean the bubbles off your screen. That's funny. So here, Lilaba, I'll show you what we're doing. I'm going to add an Alka-Seltzer tablet to this. By the way, my battery's getting low. I don't know how long I'm going to be able to hang in there. So if I go offline real quick, you know what happened. So in goes the Alka-Seltzer tablet. It produces a lot of bubbles. And the bubbles form as sodium bicarbonate in the Alka-Seltzer tablet reacts with citric acid. And those two react and they form carbon dioxide. and the carbon dioxide's a gas, and the gas shows up as bubbles. And Lullaby, what I want you to notice is, where do those bubbles end up? I mean, I see them out here on the side, but boy, they sure do seem to be concentrated in the middle, don't they? They're concentrated in the vortex and in this middle here, which is kind of interesting. And you can see it even better once everything kind of calms down. I can hear the bubbles. I don't know if you all can. I'll get the camera closer, see if you can hear it. I don't know if you can hear that or not. I hear it foaming. Anyway, yeah, now we've seen that it's cleared up. And we also see that the bubbles are trapped in the vortex. I got off kilter somehow, and I don't know what I did. All right. So now what I'm going to do is I'm going to add some sodium hydroxide to this flask. And that's going to react with the carbon dioxide that's in the funnel. Those are carbon dioxide bubbles. So as I add, check it out. Look at that, man. Look how quick that went. So the reason why the bubbles disappeared and now the vortex is transparent again is because the bubbles are made of carbon dioxide. That may happen, Tracy. Yep. The carbon dioxide reacted with the sodium hydroxide and turned the carbon dioxide into basically sodium carbonate, which dissolves in water. And that's why they disappeared. I think that would be the case. Unfortunately, I don't have any soda or beer down here in the basement with me. So I can't try the beer. But the I'm Dead channel, I wouldn't chug this. I mean, if I chugged it right now, I'd probably end the live. I'm guessing in maybe 10, 15 minutes, because one of the dyes contained in here is a laxative, and that'd be a bad afternoon. Okay. Hey, we got to 100. We got to 100 there for a bit, which is kind of fun. Let's pop this other one on for folks who may not have seen it. This is the one I call Rainbow Indicator. Looks orange right now. And I'm going to add some acid to this, and we're going to see what happens. So here we go. Let's add a little bit of acid. And you might notice the color change to red. Is that similar to the salts in our sweat oil, especially from our nose, breaks down the head of the beer? Carl, what I think's going on when the head of a beer breaks down is when you put your finger in the head of a beer, your finger produces a surface on which the bubbles can pop, is what I think's going on there. Anyway, let's add a little bit of base to this. And you can see when I add base, there's a blue color in the vortex. And it takes a bit to react. There it is. We got the rainbow, just like that. Just like that, we got the rainbow. I'm going to slow it down so the rainbow lasts a little longer. So what's going on in this particular flask is there's a mixture of chemicals in there that we call universal indicator. And universal indicator changes color depending upon pH. Right now I'm adding acid, and so the pH goes to red. What if you use soda? It'd be interesting to try. I do a lot of experiments with soda. Now I'm adding base. So the dead channel, you're saying I should do this and then do it with soda water and see what happens. I do some experiments with that. So when you add the universal indicator to soda water, it turns red because the soda is indeed acidic. But it would be interesting just to try it. Thank you there, Lullaby. That's a great idea, I'm Dead. I mean, you can mess around on my channel, look around either here or on TikTok. You can see a few experiments I've done with these are acid base indicators with soda, but the one you describe in particular sounds like an interesting idea. It really does. So we'll add a few more drops. Very nice. All right. Well, you know what? Heisenberg. Dr. Hayes is calling me Heisenberg. Come on, man. Come on, man. This ain't I don't make stuff. I just make stuff look pretty. Oh, that's funny. Quinine, excuse me, I don't know how to say that compound. Quinine, UV rainbow. That would be interesting to watch. The issue with quinine, if I remember correctly, is under the UV light, it looks blue. And it does change with pH. If I remember correctly, it shows up in acid but not base. No, you're not spelling it wrong. Every teacher's Walter. That's funny. Um, yeah, but I think we'd only see blue or colorless with that. And I don't want to mess around with a whole bunch of UV light. That's funny, Lilaba. So right now we're seeing green. That's pH neutral. Neither acidic nor basic. If I add a little squirt of acid here, it's going to go red. All right, y'all. I think I better end it for tonight. I appreciate y'all hanging out with me. That's awesome, Canoe. Thank you there, Dr. Hayes. I really do appreciate y'all hanging out with me. Here, I'll what I normally do at the end, we'll just switch this around, so I'll say hi to y'all. And I'll turn this off. You can see my ugly mug in case you care. If you don't care, that's all right, too. We're going to lose some viewers pretty quick here. So thank you, Tracy. Glad to hang out with you. And Rachel, thank you, Canoe. Appreciate that. Thank you, Carl. I appreciate you. Appreciate all of you hanging out with me this evening. And this is something I plan on doing a little bit more. I guess I can take these off. I'm done doing the experiments. So, yeah, thanks for hanging out. And we'll. I hope I sleep well tonight. Yeah, thanks for hanging out. Thanks for looking at some of the beauty of science with me, and we'll be seeing you around. All right, folks. Have a great evening. So long.